morning, friends. I am here again for my course, Aircraft Stability and Control. Today it is my lecture number 48. In this tutorial, we are going to discuss about demonstration of aircraft for lateral stability aspects. And these questions will be discussed, that what is the lateral static stability. In this, we are going to discuss about numerical to find DeltaE to trim the aircraft at particular coefficient of lift, then calculation of elevator control power, that is CM DeltaE. We are going to discuss about what do you mean by elevator control power? How does the graph changes for trim versus elevator deflection? So these I am going to discuss in this topic. So first I should focus on what is the DeltaE. So I will take this aircraft. If this aircraft is flying like this, I want to change its attitude. This attitude can be changed in longitudinal direction, means pitching. It can be done by the help of elevator. If I want to make nose up, it means I want a force which should be pulling down. It means what? Your elevator should go up. So if elevator will go up, a force will be generated in this direction and it is pulling up like this, and aircraft will be nose up. If I want to make nose down, our force should act upward. So this upward force will try to pull like this. So what we have to do? The elevator, which is one of the primary control for any aircraft, and in this case, if you want to make the force upward, your elevator should go down. If the elevator is going like this, downward, the wind is coming from this direction, a force will generate in this direction. So the tail will go up and nose will go down. So the elevator control is used to make the aircraft pitch up or pitch down. And just now I have explained what is the pitch up and pitch down. And how much DeltaE required to trim the aircraft at particular coefficient of lift. So for the cruise, we have lift is equal to weight. If you see for other conditions like maneuvers and all, lift will be higher than weight, and L by W is called the load factor. So as the load factor increases, the requirement of elevator will also vary. So these aspects we are going to discuss today's class, and you will see that a very good result will come out by doing so. So CL of trim, so here we can see that CL trim for various CG locations. Here we can see a plot of coefficient of moment versus coefficient of lift, and you see that this dCm by dCl should be less than 0, or it should be negative. So if you want to trim this aircraft in this condition, at this CL, how much DeltaE is required? So the variation of coefficient of moment versus coefficient of lift is given in this plot, and this shows the stable condition. So to have the stable condition, the dCm by dCl should be less than 0 or negative, and or dCm by d alpha should be less than 0. So here if you see dCm, this slope of this plot is negative. This slope is negative. Okay, so dCm by dCl is less than 0, and as dCm by d alpha is equal to, we can write dCm by dCl into dCl by d alpha. So this dCl is cancelled out. So for dCm by dCl into dCm by d alpha. So this point 1 is the given plot shows Cl trim, as in this point Cm is equal to 0. So here if you see this plot 1, it shows the condition for which the aircraft coefficient of lift at this you don't have any Cm. So it shows that at dCm by dCl, if it is 0, this is the point where it is called the trim point. So the point 1 is the given plot shows Cl trim, as in this point Cm is equal to 0. So if you see here at 1, this is Cm is equal to 0. If you see the another condition here, to have the longitudinal static stability, two conditions have to be met. So first condition, dCm by dCl should be less than 0, and Cm naught here should be greater than 0. So by seeing this plot, we can see that our aircraft, the plot for this aircraft shows that aircraft is in longitudinal static stability. Now we also know that dCm by dCl is equal to minus static margin, and this static margin is what? XCG, the difference between CG and NP. Just I want to show what is the meaning of CG and NP. If this is the aircraft, so this is the NP, neutral point, and this is the CG. And if we are calculating from here, this is the X bar CG, and from here to here, this is the X bar NP. So the dCm by dCl is the difference between center of gravity and the neutral point. As here, if you see in this case, what I have given, it shows the minus. So it is equal to minus Sm, where Sm is called static margin. So the slope of this dCm by dCl is depend upon the CG location. So you see here, if this CG is moving towards this point, this Sm will increase, means more static, longitudinal stable. And as it is moving towards this, up to this point, if I draw the plot here, just you see, this is the CL and this is the CM, and I am writing here this is a 1, 2, 3 CG location. And if you see, if I draw the plot for the 3 CG location, from starting from 1, so this is more slope, means this is the for position 1. Then second is position 2. Then third is position 3. And if it is reaching to this neutral point, both places, then NP and XCG will be same. If this is the point, here it will be parallel to this, and this is called the neutral position. This is called neutral position, and aircraft will maintain the neutral position as and when it is reaching to the correct situation. So if you want to make this aircraft neutral stable, the center of gravity of this aircraft to move towards the aerodynamic center or neutral point, as and when it is reached to this point, this aircraft will become neutral. As we further move the CG location behind neutral point, then aircraft will be unstable. So, as far as the requirement of this thing is concerned, we should make sure that aircraft is not, the center of gravity of the aircraft should not go beyond the neutral point, and we should ensure that aircraft is, the CG is ahead of the neutral point. So we can see that the slope of the dCm by dCl is depend upon the CG location. I have shown in this plot, and this XCG neutral point is, what is the neutral point? It is that CG location where dCm by dCl is equal to 0. That we have to see very much clearly, that if the XCG coincides with neutral point, the static margin of the aircraft will be 0. So there, for the neutral stable aircraft, SM is equal to 0. It means what? The XCG lies to XNP. So there will not be any momentum and it will maintain the aircraft. Just I want to explain by the help of this aircraft. If aircraft is flying, there are 10 passengers inside this. Neutral point is behind, the aerodynamic center is ahead and neutral point is behind. Some of the people, they start shifting towards the backward. One situation will come where the more people are going backward, then XCG, the center of gravity of the aircraft, will try to move. If the center of gravity is moved in such a way that the center of gravity is overlapping or coinciding with the neutral point, in that condition, whatever condition aircraft is maintained, that will be only maintained. It will not come to its original position. If it is disturbed like this, it will maintain like this, it will fly like this only. So, to have a proper stable aircraft, we should ensure that the CG of the aircraft should be always ahead of the neutral point of the aircraft. Otherwise, it will, and if little behind it goes, aircraft will be unstable. So, it will, unstable means what? It is disturbed like this and it is going like this, away from this thing. And stable means if it is disturbed, it is trying to come to its equilibrium position. If this is happening, we can say that aircraft is statically stable. So, we have learned that the deflection of the elevator required, delta E is equal to delta E naught plus d delta E by dCl trim into CL trim. It is missing here, but it should be CL trim. So, we know that d delta E by dCl trim is equal to minus dCm by dCl into Cm delta E. Here we can see that if we deflect, this is the delta E required and this is delta CL. So, and how much Cm? So, this Cm divided by this dCl and is divided by control power Cm delta E. So, if you deflect positive, you will get a negative Cm. This indicates here minus sign. This minus sign from where we got? We got from here. If it is like this, this is the alpha, and if you deflect this delta E, this deflection of delta E will generate a lift in this direction, and there is a LT from here to CG. LT, this CL into LT will give the Cm, and this Cm is minus because it is a nose down tendency. So in this way, we can calculate the delta E required for the aircraft by this equation. Now, so pitching moment due to positive delta CL generate a negative delta Cm. This is called Cm delta E less than 0 or negative, and this is called the control power. Okay, so control power is dCm by d delta E. Just I want to explain again for this Cm delta E. So if I take this Cm versus delta E, so if I draw the plot at this Cm, it is a Cm1. Here, this is the delta E1. This is the Cm2. This is the delta E2. So, delta Cm by delta E is equal to what? It is a Cm2 minus Cm1 divided by delta E2 minus delta E1. So, this is called dCm by delta E. Okay, so this we have to ensure that you should try to understand this, that control power is difference between Cm and delta E. So now we have the numerical. For an aircraft, following data are given. Neutral point is given at 0.5. Static margin is 30%. CL trim is equal to 0.6. Delta E is equal to 0. CL trim is equal to 0.4. Delta E is equal to 4 degree down. Okay, so I will just we have to understand that here static margin is given 30%. So we should understand the physics of this problem. Here neutral point is given, SM is given. So what is the SM and neutral point? I will just explain. This is the neutral point and this is the CG and this is called the SM and this is given 30%. This is given 0.5. So we have to find out what is the location of CG. We can find out very well, and also because we know that SM is equal to XCG minus XNP. So here XCG is equal to SM plus XNP. So SM is 30 means 0.3, NP is 0.4, so it is a 0.8. So like this we can calculate the CG location or NP. If two things are given, we can do that thing very, very nicely. Okay, so we have to calculate elevator control power, that is Cm delta E. If new CG is at 0.4 C, then what will be the CL trim for delta E is equal to 0. So these are the here two issues which we have to handle, and we should try to find out this elevator control power. Okay, so the things which are given here, if you see, given value at CL trim 0.6, at delta E is equal to 0. So here, you see here, this is the point. In this, I have drawn the Cm versus CL, and this is the CL is equal to 0.6 when delta E is equal to 0. So this is the condition. The second condition is when CL is equal to 0.4. Here, if the CL is 0.4, delta E is required is 4 degree. Okay, so in this condition, delta E is plus 4 means it is downwards. So plus 4 means it will generate force here, it will generate a nose down. Cm delta E will be nose down. Okay, so if I draw the plot from here, this from here to here, this is called delta E required now. And this is here minus delta E. But we have to counter this minus by plus 4 degree. That we have to understand very much clearly, that delta E is equal to 4 down. So here if you see, If you take from here, this is your reference line. The SM static margin is given 0.3C. XCG and NO is given, neutral point. We know the delta E required. Delta E required is equal to delta E naught plus d delta E by dCl trim into CL trim. So, here delta E naught is equal to minus Cm alpha by Cm delta E, and d delta E by dCl trim is equal to minus dCm by dCl divided by Cm delta E. So, now I have to find out d delta E by dCl trim. Okay, so just you can see here what is this meaning of this is the delta E by dCl trim. So here it is 0. It is 0 delta E, and here is 4. Okay, so d delta E is 4 minus 0. And if you draw the plot here, this is the 0.6 and this is 0.4. Here in this you can see. So 0.6 minus 0.4 are 4 minus 0 divided by 0.4 minus 0.6. So here you will get 4 divided by minus 0.2. So here you got minus 20 degree. This much d delta E by dCl trim is required, minus 20 degree. Now delta E by dCl we got minus 20 degree. So one term of this one we have received this. Now we have to find out other term with respect to the given condition. Now our aim is to find out Cm delta E. The first question is Cm delta E. We know that the d delta E by dCl trim is equal to minus dCm by dCl divided by Cm delta E. So d delta E by dCl trim we have to find out 20 degree. So now we have to how to get this number. Okay, so we know that static margin Sm is given by dCm by dCl. So this dCm by dCl is called static margin, and it is given 30% or 0.3 C. It is given. So dCm by dCl is equal to minus static margin or minus 0.3. It is given. This number is already given, and this is also given. So it is very easy to find out Cm delta E. So here minus 0.3 divided by Cm delta E is equal to minus 20. So Cm delta E is equal to this minus is equal to plus 0.3 divided by minus 20. So we got here minus 0.015 per degree. This we got. Cm delta E means the control power, which the question 1 is asking, how much is the control power of this aircraft. So we can say that the Cm delta E of this aircraft is 0.015 per degree. So we got the answer for the elevator control power. Cm delta E is equal to minus 0.015 per degree. Minus means what? So we need to deflect down. If you see here, this is the horizontal tail and this is your elevator. It is hinged here. So your Cm delta E should be negative. This is the Cm and this is the delta E. It should go like this. Means it is a negative slope. So you have to make like this. This is called plus 4 degree. So we have to understand the physics, and this will generate a lift in this direction and lift into this LT. This is the CG and this is the LT. This L into LT is equal to Cm, and this Cm is negative because it is in anti-clockwise direction. So your control power is minus 0.015 per degree, and it is showing that aircraft is nose is going down. Okay, just I am explaining here again. What is the meaning of here? The control power means how much you deflect the elevator and how much you get the nose down tendency. So if you deflect the elevator down, it is a positive delta, and positive delta will generate a positive lift upward, and this lift into this distance will try to give the moment negative. So this is called the control power, Cm delta E, and Cm delta T negative means it is a nose down condition of the aircraft, and nose down means it is a longitudinal static step. So I am going for the next issue, and you will see here that how we are going to handle the situation of the second part. If the second part is what? If the new CG is at 0.4 C, what will be the CL trim for delta E is equal to 0? So the CG location is now shifted to 0.4 C, and what will be the CL trim for delta E is equal to 0. So here in this case, the static margin will not be same as the X CG is changed. We need to find out CL trim. Some assumptions we have to make in our solution of this problem. CG has changed, so LT will also change. That will affect the Cm delta E, Cm naught. But we assume that they are not affected by this. So we can see that if we change the CG here, this is the CG and here is the AC of tail. So what we have assumed that if initially it is here and now it is changed to new position 0.4, but we are assuming that this LT is remain constant, but in fact it is not true. But we take the assumption to have some understanding and to minimize this aspect of this problem. Here we have drawn the plot of delta E versus CL. We have to find out what is this condition CL trim. CL trim means at delta E is equal to 0. The value of CL at which delta E is equal to 0. So here it is given that it is the CG location is 0.4 C, and in this case delta E is equal to 0. So delta E, what is the meaning of trim? Aircraft is flying like this. For the trim condition, lift is equal to L is equal to weight. Lift is equal to weight. So in this case, if I draw here a small aircraft like this, if you see this is the lift and this is the weight, this is the thrust and this is the drag. So in this case, L is equal to W, T is equal to drag. So this is the condition for a cruise trim condition. Oh, this is the condition. So now we have to see that the new location of CG is here 0.4. What will be the CL trim? This we have to find out, and again we have to use the equation delta E is equal to 0 and delta E is equal to delta E naught plus delta E by dCL by trim into CL trim. This equation is very famous to find out the delta E or the elevator deflection required, and we have so many times we have used, and previously we have discussed and derived this equation many times. So here we have to further see that what is the d delta E by DCL trim. D delta E by DCL trim we can write is minus DCM by DCL, and this minus DCM by DCL is equal to what? It is a minus XNP minus XCG or XCG minus NP. XCG is now 0.4 minus 0.5, so it is a minus 0.1, or this is called 10% of the chord. Okay, so what is the meaning of 10% of the chord? So from this distance to this distance, this is the 10% of mean aerodynamic chord. So previously it was 30%, but now due to this shifting of this, so we can understand that in the previous case the XCG was ahead, much ahead. Then only, so how much ahead? It was at 0.2. If you make 0.2 this one, then the value will come 30%. So if you see the previous case, if I make like this, this is the 0.2, this is the 0.3, and this is the 0.5. Okay, and this is 0.4. So previously it was here. Now it is shifted 0.3 to 0.4. Okay, so that is the benefit. So now previously it was here, now it has reached to here. This much it has shifted from here to here. It means the static margin is reduced 20%, and aircraft stability also. Aircraft stability also reduced by 30%. Okay, that is the meaning. Okay, so here delta E is equal to delta E naught plus minus DCM by DCL divided by CM delta E into CL trim. Delta E naught is equal to minus CM naught by CM delta E. So minus this is equal to minus 0.8. This we can see here. Here it is slope we have got minus 0.3, and so this CM naught is how much? This is 0.6, so 6 3 ja 0.6 into 0.3. You see this perpendicular is equal to perpendicular this A, B and C. This AC is given 0.6. This BC is given 0.3. So we can find out the AB is equal to what? AB is equal to AC into BC. AC is 0.6, BC is equal to 0.3. So we got here 0.18. So here we got this value minus 0.18. Okay, because here is minus, and CM delta E we have already find out that it is minus 0.015, and if we make it, so we will get here that 18 by 180 by 15. So here we got 12 degree. So delta E naught is equal to 12 degree, which we can get from this calculation. Now we have to see that delta E is equal to delta E naught plus minus DCM by DCL into CM delta E into CL trim. So delta E is equal to 0 for trim. So this we have made as a 0 because there should not be any delta E for trim condition. So this we have made. We have find out this delta E is equal to 12 degree plus here DCM by DCL is equal to static margin, and static margin is XCG minus XNP divided by CM delta E into CL trim. So we have to find out what is the CL trim. Okay, so here 12 plus XCG 0.4 minus 0.5 divided by 0.015 CL trim. So 12 plus here 0.01 divided by 0.015 CL trim. So now CL trim is equal to what? So TL trim is equal to 12 into this 0.015 and divided by minus 0.1. So you will get here 1.8 degree. So you will get here what? This is also minus. So this is minus, 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 plus this degree. So you got the CL trim is equal to 1.8. It is not degree, it is a CL is 1.8. So the trim CL will be 1.8 for new CG location. So if I want to draw the plot for this condition, so what will be the plot? Initially it was 0.6 CL and this is the delta E. So for this delta E, what will be the, initially it was like this, but now the CM naught is same. So we have to, now it is a 1.8. So 1.8. So this plot will go like this. So this is the new case where CL trim is equal to 1.8. So in this much, so the trim CL will be 1 point for new CG location. So if the CG is coming near the, if the CG is coming near the neutral point, then CL trim will be higher for the trim condition. Means if the delta E is equal to 0, then we have to do the same. And another thing, if you see here, if you extend this line and for this CL case, how much CL, this delta E is required. So this is the delta E. Means this much delta E is required and this is the negative delta E. So you have to deflect down. This much you have to, this is the delta E negative. It is creating. So we have to counter by positive. So positive means we have to deflect your elevator this much positive deflection of elevator needed. Okay, so this is the criteria, and in this way you have to understand that these are the things required for the, okay, so I have taken the references from NPTEL lecture. This is from Aircraft Stability and Control by A.K. Gross and Robert C. Nelson for this. For any query, you can contact me to this ydwivedi@gmail.com. Okay, so you are welcome to ask any question in this. I will try to discuss. Okay, thank you very much for joining this class. Hope you will be joining my next class also. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.